Hello everyone, hope everyone doing good. So yeah, welcome to Standard Solver. So I thought I will do a quick tutorial on how to solve a truss using Standard Solver. I have done similar tutorial before, but since then I have kind of revamped the frame analysis 2D module quite a bit. So I thought I will do a new tutorial. So yeah, let's go to standard solver and go to frame analysis module. Uh, and so this the truss we want to model, and this is the result actually. So this 30, 65, 50, these are the member forces we want to calculate using standard solver, and this is the support reactions. So let's model this problem in standard solver and see whether we can get the same results. And we can kind of check the new features we have in standard solver as well. So okay, so we have, when you go to this module, we have this model. So let's clear all the elements in this model and make it blank. So remove the restraints, load, let's remove the element. Let's delete the node. So yeah, now we have a blank canvas. So let's start modeling from here. So 0, then let's do point C, which is 6 meter up. 6, then node E is at 12 meter up, so 12. Then let's make this on B, which is 5 meter in the x direction. Then D is actually midpoint of for this 5 meter element and 6 meter above, so we can put 2.5 and 6. So we got all the nodes required. So let's create the elements. So n1 to n2 we just keep it as frame, section as default. So yeah, we'll just leave that to n3, then n1 to n4, then n4 to n5, then n5 to n3, then n2 to n5. So yeah, we need to go to next page. N1 to n5. So we got all the elements. Let's now add the restraints. So we have pin here and a roller here. So n1 we pin it, n2. So roller gives only vertical support. So just want to give at n4. Yeah. Okay. So this being a truss, we want to have pin joints between elements. These are rigid connections. So what you do, earlier we used to release each element, which used to be kind of more time consuming to do it now, because you can release it in much different ways nowadays with this new module. What you can do is like release nodes. So then you get this green symbol. What it does is this kind of allows the elements to rotate about that node without transferring moments between each other. Even, what I found is even you run without these nodes, there won't be much moments in the elements because these are fairly long elements. So yeah, so this is how you do the truss joint in the new frame and truss analysis module. You just release the nodes. I think this is done in different FE programs like SAP in similar style. So okay, so let's continue. Let's enter the nodal load. So node 2, we have a 50 kilonewton in the x direction. Node 3, we have similarly in x 25 kilonewton. Again in node 3, we have in the global y direction there is a minus 30. So it will go to the minus y direction. So I think we have everything required. We don't want to include any self weight. So let's run the analysis. Let's see what it comes up with. So okay, no moment, no shear. So the pin connections are working. Even you don't release it, it will be 0. So yeah. So we got the results. We can see the reactions are 75 90 75 90 120 at this point. And the element forces also looks nice. So this element is 50, this also 50. Oh, I want to show a new feature. What you can do is now switch off the elements you don't want to see. So this element which has a force of 65, you can see 65 here, yeah. So we want to check this element between these 2 points like N2 and N3. What was the element there between N2 and N3? Between N2 and N3 was E2. So let's switch it on. Now we can see 30. Yeah, earlier it was more cramped, but now you can switch on and off different elements. Okay, let's switch it back on. You can sometimes it says like you can double click on it, then it will just keep only that element. Let's give it a try. Yeah, it is quite temperamental, but it works. So you see like 130 for this element. So yeah, so we are matching the result from a textbook. Yeah, quite easy to solve these problems straight away. You don't need much setup. So give it a go. Hope you enjoy StandardSolver. See you next time with another tutorial. Yeah, have a good day. Bye.